All right, so let's just sort of hammer this one out. Imagine you've got three vectors in Rn. Let's just look at their dot product, and essentially what we're going to show here is that you can distribute a dot product across a sum of two vectors. Again, this is just a fact. It will prove useful to us, but well, shoot, let's just go through the computation. So to do this, we can just look at the left-hand side and the right-hand side separately, and ultimately show that both sides of the equation are equal. So we'll do just that. So imagine we're dotting this vector times that vector. You know how to dot vectors, it's just component by component. So to imagine this, imagine you've got your u1 through un, and you are dotting it with the sum. Now, what is the sum of the two vectors? Well, you know how to sum two vectors. In particular, take the v1 to the vn and the w1 down to the wn. When you sum the vectors, you sum them as always, just component by component. So whenever you do this sum here, you'll end up with v1 plus w1 down to vn plus wn. And now let's think about this, because we're taking a dot product, and whenever you do the dot product, that just means you multiply the components together and then add it all together, which will give you just a single number. A single number, as we've discussed previously, corresponding to the angle between the vectors, whether the angle be acute, obtuse, or orthogonal. But the long story short is whenever we compute this dot product, we get u1 times v1 plus w1, u2 times v2 plus w2, all added together out to un times vn plus wn. Okay, so this is a single number. This would be the single number which is corresponding to the dot product of u dotted with v plus w. And then the question is, what would be the right-hand side? Well, as you can see, the right-hand side is the dot product of u and v plus the dot product of u and w. So what would that look like? Well, that would be taking u and v and first dotting. You're going to get just a single number here, right? Because whenever you do a dot product, it's going to be, well, in particular, shoot, let's just hammer this out. This is going to be u1 v1 times u2, or well, plus u2 times v2 plus out to un times vn. And now what's going to be added to this? We're adding to this u dotted with w. And so what's that going to be? Well, as you dot product any two vectors, you just multiply the components and then add together. So this is going to be u1 w1 plus u2 w2 out to un wn. And the long story short is here you notice that you have multiple terms with u1s. Each of these bits of the expression at this stage are just real numbers being multiplied together. u1 is not a vector, u1 is just a number. v1 is not a vector, v1 is just a number. So we've got a bunch of these numbers being multiplied and then added together. If we simply rearrange, we get u1 times v1 plus w1, and then we could have u2 times v2 plus w2, all the way out to un times vn plus wn. And the long story short is whenever you look at the left-hand side and the right-hand side, the two sides are equal, so we have our fact in tow, which is to say, in effect, dot product distributes across a sum.